Okay, let's start with example number 1. So this is a very classic soil three-phase problem. We have the wet weight, we have the dry weight, we have the total volume, and we have the specific gravity of the solids. The question is asking for a void ratio. So feel free to pause the video and work on the problem first, and we'll be back very shortly. Okay, so we're back. Well, first of all, just want to refresh your memory on the definition of void ratio. Well, the definition of void ratio, E, is the volume of the voids over the volume of the solid. Questions like this are pretty hard to solve if you just want to use the equations. So I would encourage everyone to try to plot the three-phase and just try to figure out every components, both on the weight side and on the volume side. So let's do that. It does not really say anything about whether the soil is saturated, so you should always assume that in the soil you might have air, you might have water, and of course you would have some solid. And we know the wet weight, so I typically put the weight information on the left and I put the volume information on the right. So the total weight is 205 and the total weight is 220 and the dry weight is 205. So we have 205 over here pounds and the total is 220. So, and usually we would neglect the weight of the air, so the weight of the water is actually water would be 220 minus 205, which is 15 pounds of water. So you have 15 pounds of water. Okay, and specific gravity of the solid is 2.65. So we also already know the weight of the solid is 205. So basically now we can cross the little bridge using the specific gravity. If you have a specific gravity of 2.65, you would know the unit weight of the solid is 2.65. Everything is in pure unit, 62.4. That's the unit weight of water, PCF. So with that, our gamma S would be 2.65 times 62.4, which is 165. I would put a 0.4 again. For FA exam, you don't really have to keep too many decimals. Just try to keep the calculation kind of as simple as possible. So you have the gamma S, then the volume of the solid would be (205) over 165.4 PCF. Then the volume is 1.24 cubic foot. So after you get the 1.24, you don't actually have to calculate the volume of the water anymore. But you could, because you already know the water is 15 pounds. Because the question is only asking you for the void ratio, you already know the total volume of the whole thing is 1.73. So you would know the volume of the voids is essentially 1.73 minus 1.24. That would give you about 0.49 cubic foot. So your void ratio is 0.49 cubic foot over 1.24 cubic foot. That is 0.395, close to 0.4. So 0.4 is definitely the right answer. Although this question itself does not really ask you about the volume of the water or the volume of the air, but you could have scenarios that the question might want to ask you, for example, the degree of saturation. So if you recall the definition of degree of saturation, that would be the volume of the water over the volume of the voids. And sometimes we throw a 100% there because usually the degree of saturation is expressed in percentage. So let's say if the question would want to ask you the degree of saturation and how we're going to approach this problem. Well, you actually have already know the volume of the voids. So this is 0.49. Then the question is, what is the volume of the water? Well, you already know the weight of the water, which is 15 pounds. So the volume of the water would be the weight of the water over the unit weight of water. We have 15 pounds over 62.4 pound per cubic foot. So that would give us 15 over 62.4, using my calculator right now. So we have a 0.24 cubic foot. Then the degree of saturation would be 0.24 over 0.49 times 100%. That is about 49%. Okay. And now you actually are able to find every little part of this three-phase diagram. Okay, so that is problem number 1.